We will hopefully now finish section 4.4 on the fundamental theorem of calculus. And by doing that middle thing that we had skipped in the last video, titled mean value theorem for integrals. So the mean value theorem for derivatives that we did earlier in chapter 2 was to find a tangent line that is parallel to a secant line. So I want to find a line with the same slope. They were parallel. So now with the mean value theorem for integrals, I want to find something with the same area. And what I'm going to find is a perfect rectangle. It's going to have the same width as the area I'm talking about, but it's going to be a rectangle and not be a curved surface. So it's going to be easier to do. So the mean value theorem using derivatives, I found two lines with the same slope because derivative is slope. So now the mean value theorem for integrals, I'm going to find another shape that has the same area. So the actual formula for the mean value theorem for integrals is the integral from a to b of f of x dx. So that is the integral, or the area between the x-axis and a curve from some values x equals a to x equals b, is going to equal f of c times b minus a. So when we do this, as I said, the integral we know is the area. That's what we've been working with. But now f of c, this is my y value. That's going to give me my height. The b minus a is going to give me my width. So if y is my height and b minus a is how wide across the bottom of it is, that's going to give me height times width, or a rectangle with the same area as the area under the curve. All right, so how are we going to do this? This is going to be a two-step process. The first step is going to be to find this area. We can find this exact area. That's what we have been doing. So the problem we're going to do with this is we're going to find the area. We're going to find the value of c guaranteed by the mean value theorem for integrals for this function over the given interval. So f of x is x squared plus x on the interval from -12 to 0. So as shown in this formula up here, the first thing we want to do is find the actual integral from -12 to 0 for this function. So that's going to give us the integral from -12 to 0 of x squared plus x dx. So we've been doing this for a little while now. Hopefully this is not that difficult. So first take the antiderivative. X cubed over 3 plus x squared over 2. And I'm going to evaluate that from -12 to 0. All right, so I need to plug in -12 first. I'm going to need to plug in 0 first, so it's the top minus bottom. So when I plug in the top, I'm going to get 0 over 3 plus 0 over 2 minus, plug in my -12. So -12 cubed over 3 plus -12 squared over 2. Well, this first bracket over here is pretty nice. 0 over 3 is 0. 0 over 2 is 0. So the whole thing is just 0 minus. Do not forget to write this. People think it's 0 and they don't have to write it. You have to write it because then you forget this minus sign here. We need this negative here. All right. So -12 cubed. -12 cubed is -1728 over 3. Plus -12 squared is 144 over 2. So I get 0 minus bracket 1728 divided by 3 is 576. So it's a -576 plus, and then 144 divided by 2 is 72. So I get 0 minus -576 minus 72 is going to give me a -504. But minus a negative is going to give me +504. All right, so that is my actual area that I'm looking for. This is just the left-hand side of my formula. So right here, or right here, the integral from a to b of f x dx. Now, I need that to equal f of c times b minus a. F of c is just your function. C and x are the same thing. C is just a very specific x. So I'm going to rewrite this as f of x and find x. And then b minus a, that is my width. That is what I am integrating my upper and lower bounds with. So this 504 is going to equal my function. So my function from scrolling back up right here, x squared plus x times b minus a. So again, go back up to our integral. Remember, this goes from a to b. So b minus a is 0 minus negative 12. So 0 minus negative 12. All right, so now if I solve this equation, I can go ahead and find x, and that is what I am looking for. All right, so I'm going to get 504 equals x squared plus x times 12. The easiest way to solve this is you can't have these parentheses, so divide each side by 12. When we divide each side by 12, 504 divided by 12 is 42. So I get 42 equals x squared plus x. This is a quadratic equation because it is x squared, so I need to have it set equal to 0. So I'm going to subtract 42 from each side. So 0 equals x squared plus x minus 42. That is now a typical quadratic trinomial, so I can solve it by factoring it. So x and x, 6 and 7, I'm going to minus 7 plus 6. So x is negative 6 and positive 7. But remember, our interval was from negative 12 to 0. One of these values is not in our interval. We don't want it if it's not in our interval. So 7 is not between negative 12 and 0. Negative 6 is, so that is my only answer. So that's what I'm looking for. And we are good. I found the value that if I take f of negative 6, I'm going to get my y value, times my height will give me a rectangle with the exact area as the area under the curve, which was 504. All right, that concludes section 4.4. We are done with this section. Our next video will be on 4.5.